All right, magnetic fields. We've gotten a ton of requests from our listeners to do a deep dive on this topic.
Yeah, it's one of those things, right? Like it's always there.
Totally. Invulnerable but powerful.
Exactly. And we use it for so much.
Okay, so we've got a bunch of great listener questions, articles, even some historical stuff.
Oh, cool. Like what?
Well, some people were asking about how compasses actually work, with the Earth's magnetic field and all that.
Ah, yeah, the classic compass. Always a good starting point.
For sure. But I think what I'm most curious about is how we're using magnetic fields for these crazy futuristic technologies.
Oh, yeah, that's where it gets really interesting.
Like quantum computers, fusion energy, stuff that sounds like it's straight out of Star Trek.
But it's real. That's what's so mind-blowing.
Okay, so before we get ahead of ourselves, maybe let's start with the basics.
Sounds good to me.
What exactly is a magnetic field? Like, I remember playing with magnets in school. Opposites attract and all that.
Right. But what's going on beneath the surface?
Yeah, what's the invisible force at play here?
So you can think of a magnetic field like an area of influence.
Okay.
It's created by moving electric charges.
So anything with electricity flowing through it creates a magnetic field.
Exactly. The faster those charges move, the stronger the magnetic field.
Oh, interesting. So is that how those bar magnets work? Like the ones we used to play with?
Yep. Those have tiny little electrons spinning around inside, creating a magnetic field.
Oh, wow. So it's like a mini version of what's happening on a much larger scale, like with the Earth.
You got it. Speaking of Earth, have you ever wondered why compasses always point north?
Well, yeah, I just assumed it was some kind of like built-in navigation system or something.
It is a navigation system, but it's all thanks to the Earth's magnetic field.
Oh, right. We were talking about that earlier.
Our planet is like a giant magnet itself, with a magnetic field that extends far out into space.
And that's what the compass needle aligns with.
Precisely. The needle is basically a tiny magnet itself, and it aligns itself with the Earth's magnetic field lines pointing towards magnetic north.
That's so cool. So basically, we're living on a giant magnet. Does that have any other effects on us besides guiding compasses?
Definitely. It's actually crucial for life on Earth.
Oh, how so?
Well, you know how the sun constantly blasts out radiation and charged particles?
It's called solar wind, right?
Exactly. And that stuff is harmful.
Oh, wow. So what protects us?
Our magnetic field, it acts like a giant shield, deflecting most of that solar wind away from Earth.
Wow, it's like a force field. So without it,
We'd be in trouble. Life as we know it probably wouldn't exist.
so we owe a lot to this invisible force field. It's like Earth's guardian angel.
That's a great way to put it. It protects us from harmful radiation, guides our compasses, and even plays a role in animal migration.
Wait, animals use it to migrate?
Yeah. Some animals, like birds and sea turtles, have a special sense that allows them to detect the Earth's magnetic field. They use it like an internal compass to navigate during their long journeys.
That's incredible. It's like nature's built-in GPS. Okay, so magnetic fields are clearly essential for life on Earth. But what about our technology? Didn't you say they power a lot of the things we use every day?
Absolutely. And that's just the beginning.
All right, well, let's get into it then. What are some examples of how we're using magnetic fields in technology?
Let's start with something simple, electric motors.
Okay, like in cars and appliances and stuff.
Exactly. Electric motors rely on the interaction between magnetic fields and electric currents to generate motion. It's a fundamental principle that powers countless devices.
So every time I turn on my blender, I'm witnessing the power of magnetism at work.
You got it. And it's not just blenders. Think about all the electric motors in your house. Your refrigerator, your washing machine, your vacuum cleaner. They all rely on magnetic fields.
Wow, it's everywhere. And what about those giant wind turbines that generate electricity? Do those use magnetic fields too?
Absolutely. They use generators, which are basically electric motors working in reverse. Instead of using electricity to create motion, they use motion to create electricity.
Oh, that's cool. So it's like a two-way street with magnetic fields and electricity. What else have we got?
How about something a little more high-tech? MRI machines?
Oh, yeah. Those are the giant donut-shaped things, right?
That's the one. MRI stands for magnetic resonance imaging, and it's a revolutionary medical technology.
It lets doctors see inside the human body without surgery, right?
Yeah.
Pretty amazing stuff.
It is, and it all relies on incredibly powerful magnetic fields.
How does that work?
It's a bit complicated, but basically, the strong magnetic field aligns the protons in the water molecules in your body. Then the machine sends out radio waves that disrupt this alignment, and as the protons realign, they emit signals that are detected by the machine.
Okay, so it's like each tiny proton in our body is sending out a signal, and the machine is piecing them together to create a picture.
Exactly. It's pretty mind-blowing when you think about it. And it's all thanks to our understanding and manipulation of magnetic fields.
That's incredible. So we've got blenders, wind turbines, MRI machines. What other technological wonders rely on magnetism?
How about maglev trains?
Oh yeah, those futuristic trains that float above the tracks. Tell me more about those.
Maglev trains, short for magnetic levitation trains, use powerful magnets to lift the trains slightly above the track. This eliminates friction, allowing for incredibly smooth and high-speed travel.
I've seen videos of them. It's like they're colliding.
Exactly. And it's all thanks to carefully controlled magnetic fields.
So are those things in use anywhere, or is it still just like a concept?
They're actually already operating in a few countries. They offer a glimpse into the future of transportation, faster, smoother, and more energy efficient.
It's amazing to think about all the ways we're using magnetic fields to improve our lives. And we haven't even touched on the really futuristic stuff yet.
Oh yeah, the stuff we were talking about earlier, quantum computing, fusion energy.
Right. Those are powered by magnetic fields too.
Absolutely. But those are topics for another deep dive.
Okay, so stay tuned, folks. We're just getting started.
Okay, so where were we? Ah, yes, the mind-blowing world of quantum computing and fusion energy. Both of these technologies are heavily reliant on magnetic fields.
It's crazy to think that something we can't even see could be so powerful.
Right, and we're still just scratching the surface of what we can do with them.
So quantum computing first. I have to admit, I'm a little fuzzy on how that actually works.
It's definitely a brain bender, but at its core, it's all about using the principles of quantum mechanics to perform calculations.
Quantum mechanics, isn't that all about like subatomic particles and stuff?
Exactly. It's the physics of the very, very small. And in the quantum world, things behave differently than they do in the macroscopic world we're used to.
Okay, so how does that apply to computing?
Well, in a regular computer, information is stored in bits, which can be either a 0 or a 1. But in a quantum computer, information is stored in qubits.
Qubits.
Yeah, short for quantum bits. And here's the crazy part. A qubit can be both 0 and 1 at the same time.
Wait, what? How is that possible?
It's a concept called superposition. Think of it like a spinning coin. Until it lands, it's both heads and tails simultaneously. Qubits can exist in this kind of in-between state, which allows them to perform multiple calculations at once.
So it's like a superpowered computer bit.
Exactly. And that's where magnetic fields come in.
Okay, how so?
Well, we can use magnetic fields to control and manipulate these qubits, to essentially program them to perform specific calculations. It's like using a magnet to guide a tiny compass needle.
So we're basically using magnetic fields to orchestrate these mind-boggling quantum computations. What kind of real-world applications could this have?
The potential is huge, E. Quantum computers could revolutionize everything from drug discovery to material science to artificial intelligence. We could design new medicines with incredible precision, create entirely new materials with unheard of properties, even crack the most complex encryption codes.
It sounds like we're talking about solving problems that are currently impossible with our regular computers.
Yeah.
It's almost hard to wrap your head around.
I know, it's pretty wild. And it's all thanks to our growing understanding of how to harness the power of magnetic fields at the quantum level.
It's like opening up a whole new dimension of possibility.
Exactly. Now, ready for another mind-blowing application?
Hit me.
Fusion energy.
Fusion. Isn't that like the power source of the sun?
You got it. It's the process of fusing atomic nuclei together to release massive amounts of energy.
And we're trying to replicate that here on Earth.
Yeah, and if we can crack it, fusion energy has the potential to be a clean, safe, and virtually limitless source of power.
That'd be revolutionary. But how do magnetic fields play a role in all of this?
Fusion reactions require incredibly high temperatures and pressures to occur, like hotter than the core of the sun.
Wow, that's hot.
To achieve these conditions, scientists use powerful magnetic fields to contain and control superheated plasma.
Plasma.
It's a state of matter where atoms are stripped of their electrons, creating a gas of charged particles.
Okay, I'm following.
So these magnetic fields act like an invisible bottle, holding the super hot plasma in place so the fusion reactions can occur.
So we're basically creating mini-suns here on Earth, all thanks to the magic of magnets.
Pretty much. It's an incredibly challenging endeavor, but the potential payoff is enormous.
It sounds like it. Imagine a world powered by clean, sustainable fusion energy. No more fossil fuels, no more pollution.
That's the dream. And it's a dream that magnetic fields might just help us achieve. It's pretty amazing to think about, isn't it? These invisible forces shaping the future of energy and technology.
It really is. This whole deep dive has been mind-blowing. I know. It's amazing to think about all the potential applications for magnetic fields. What's got you most excited about the future of this tech?
Well, for me, it's the medical applications that really stand out. Imagine being able to use targeted magnetic fields to stimulate healing, repair damaged tissues, maybe even fight diseases at a cellular level.
That would be incredible, like a whole new frontier in medicine.
Exactly. And I think we're just starting to scratch the surface of what's possible. We're learning more and more about how magnetic fields interact with biological systems, and the possibilities are just mind-boggling.
It's almost like science fiction becoming reality. Like, what if we could use magnetic fields to regrow limbs or something?
Well, that might be a bit further down the road, but who knows? The field is advancing so rapidly, it's hard to say what the future holds.
I guess that's what makes it so exciting. It's like we're on the cusp of a whole new era of scientific discovery, and magnetic fields are leading the way.
I couldn't agree more. It's an incredible time to be alive and witnessing these breakthroughs.
Well, I know I've learned a ton from this deep dive. Thanks for taking the time to break it all down for us.
It was my pleasure. Always happy to talk about the wonders of magnetism.
And for our listeners, be sure to check out the show notes for links to some of the articles and resources we mentioned today.
And if you have any questions or want to learn more, feel free to reach out to us on social media.
We love hearing from you. Until next time, keep exploring the invisible forces that shape our world.